Hello, Homo sapiens. You've probably seen a large TV screen or probably have one at your home. But have you ever wondered how these work? This is the basics of the LCD screen, also known as the LED screen. LCD stands for liquid crystal display and LED stands for light emitting diode. You'll see why later. So, the way that a TV or any digital device produces an image is by using these really small things called pixels. You've probably heard of them. Pixels are comprised of 3 smaller subpixels, which are colored red, green, and blue. And by altering the amount of light that flows through these subpixels, you can get different colors. For example, if you have a lot of light going through the red and green subpixel, you will get a yellow light. But how does this work? The human eye has a limited resolution. If you go beyond that resolution, then colors start to get mixed up. If you have a large green and red light, and you start shrinking it down and putting them closer together, you'll start seeing yellow light. This is the same thing that goes for when you mix blue and red, you'll get magenta, and green and blue, you'll get cyan. And by varying these light intensities, you can get almost all the colors. And if you put a lot of pixels together, you'll get an image. But how do they control the amount of light going through each pixel? Well, you cannot use an LED behind each pixel because LEDs can only go so small before the disruptions in the surface will cause it to break. So instead of having an LED for each pixel, you have an LED backboard. And this backboard will supply light to all pixels. But if you just have the backboard and many pixels in front of it, then you just have white light. How do we control it? Well, we use something called polarizers. Light is made up of 2 main fields, the electric field and the magnetic field. The magnetic field is always oscillating in a right angle to the electric field, and that makes a sort of plus formation. And if you polarize light, only light that is oscillating in a specific direction can pass through the polarizer. All other directions of oscillation are blocked. And when light is polarized, if you have a polarizer going in a vertical direction and another polarizer going in a 90-degree angle of that, no light will pass through. So, here are the layers so far. At the back, we have the LED backboard made up of tiny LEDs. And in front of the backboard, we have a diffuser, which basically evens out the light. Have you ever held a kinda cloudy plastic sheet over a light bulb? And you see how the light kind of gets fuzzy? Yeah, that's what the diffuser does. In front of the diffuser, we have the vertical polarizer, which will polarize light vertically. In front of that, we have the liquid crystals. And in front of the liquid crystals, we have another polarizer. But this time, it's oriented 90 degrees to the first polarizer, so it's horizontal. And then, in front of that, we have the RGB crystals, RGB color filters. And once that's done, you have a thin pane of glass which protects everything behind it, and that's basically the makeup of a TV. But what do the liquid crystals do? Liquid crystals can actually change the direction of polarized light. So from vertically polarized, it can either make the light remain vertically polarized, or it can make the light shift direction to horizontally polarized. How does this work? Liquid crystals have, well, tiny crystals in them that can change orientation depending on the electric field added. If there is electricity flowing, then there will be a slight shift in the orientation of the crystals, and that shift is what changes the light's polarization. If you have no field, then the liquid crystal will stay exactly the same and nothing will happen. The more electricity is added, the more the light is horizontally polarized, which means more light will go through. And that means that subpixel, that specific subpixel, is brighter. And by altering the amount of electricity going to each of these crystals, you can individually alter the brightness of each subpixel, which can make you individually be able to control the color of each pixel, which will be able to make you able to control the image displayed on the screen.